The Big Bang represents the absolute limit of human knowledge. But what most people don't realize is that this isn't just a temporary technological limitation. The universe itself has built an impenetrable wall around its own beginning, and that wall is written into the fundamental laws of physics. Every telescope we build, every equation we solve, every experiment we run will always stop at the same exact point. The moment before the Big Bang didn't just happen in the distant past. It exists in a state that makes the very concept of before meaningless. And the reason we'll never see past it is far more disturbing than you might think. You've probably heard scientists say the Big Bang created everything. Space, time, matter, energy, all of it exploding into existence 13.8 billion years ago. But here's what they rarely explain clearly. When physicists say the Big Bang created time itself, they're not speaking metaphorically. Time as we understand it, as a dimension that flows from past to future, literally did not exist before that moment. Asking what happened before the Big Bang is like asking what's north of the North Pole. The question itself breaks down because the framework needed to answer it doesn't exist, but the problem goes deeper than semantics. The earliest moment we can theoretically observe is called the Planck epoch, lasting an almost incomprehensibly brief 10 to the power of negative 43 seconds after the Big Bang. Before this threshold, the universe was so hot and dense that our current physics simply stops working. Quantum mechanics and general relativity, the two pillars of modern physics, give contradictory answers when we try to apply them to conditions that extreme. It's not that we haven't figured out the right equations yet. It's that the universe itself was in a state where the rules we use to describe reality had not yet stabilized into the forms we recognize today. Imagine trying to read a book while the alphabet is still being invented. That's what the Planck epoch represents. Here's where it gets worse. Every piece of information we have about the early universe comes from light, radiation, particles, anything that traveled from then to now. But there's a hard cutoff point called the cosmic microwave background. Radiation released when the universe was roughly 380,000 years old. Before that moment, the universe was opaque. Photons couldn't travel freely because matter was too dense and hot. They scattered constantly, like trying to see through fog made of plasma. No telescope, no matter how powerful, will ever see through that barrier. It's not a technological problem. It's a fundamental property of the universe itself. The cosmos has effectively erased all direct visual evidence of anything before that point. But scientists are clever. They found other ways to probe earlier moments using particle physics and cosmology. By recreating conditions similar to the early universe in particle accelerators, researchers can test what matter behaves like under extreme energy. These experiments have pushed our understanding back to fractions of a second after the Big Bang. We've confirmed predictions about nucleosynthesis, the formation of the first atomic nuclei. We've detected patterns in the cosmic microwave background that match theoretical models of inflation, a brief period of exponential expansion in the universe's first moments. These successes make it feel like we're closing in on the ultimate answer. We're not. Every step backward in time requires exponentially more energy to simulate or observe. The Large Hadron Collider, the most powerful particle accelerator ever built, can recreate conditions from about 1/trillionth of a second after the Big Bang. Building a machine capable of probing significantly earlier moments would require energy levels that dwarf anything remotely feasible with current or foreseeable technology. We're talking about energies that would require accelerators the size of planetary orbits or even larger. And even if we built them, we'd still hit the Planck wall. Beyond that point, we need a theory of quantum gravity, a framework that unifies quantum mechanics and general relativity. We don't have one. We might never have one that's testable. Think about what this means for a moment. The universe has placed an expiration date on human curiosity about its own origin, not because we're not smart enough, but because the universe itself destroyed the evidence, and it's not even malicious, it's just physics. The very laws that allow us to exist are the same laws that prevent us from ever knowing where we came from. Does that make you feel small? It should. Now here's the twist most people miss. The biggest barrier isn't actually the Planck epoch or the cosmic microwave background. It's something far more fundamental and inescapable, the nature of time itself. Even if we somehow developed a perfect theory of quantum gravity and could peer back to the very first instant of the Big Bang, we'd still face an impossible question. What caused the Big Bang? What existed before it? And this is where physics breaks down completely, not because we lack data, but because the question might be logically incoherent. If time itself began with the Big Bang, then there was no before. The word loses all meaning. Causality, the idea that every effect has a cause, relies on time flowing in a specific direction. Without time, there is no causality. The Big Bang doesn't need a cause in the traditional sense because causes require time to operate. Some physicists propose models to get around this. The cyclic universe theory suggests the Big Bang wasn't the beginning, but rather one in an infinite series of expansions and contractions. The multiverse hypothesis posits that our universe is just one bubble in an eternal inflating cosmos where big bangs happen constantly. These ideas are elegant, intellectually satisfying even, but they're also fundamentally untestable with current methods. We can't observe other universes. We can't measure cycles that occurred before our own. These models might be true, but they shift the problem rather than solve it. If the multiverse is eternal, what started the multiverse? If the cycles are infinite, what began the first cycle? You can keep asking what came before forever, and you'll never reach a satisfying answer. The universe doesn't owe us one. Here's another uncomfortable truth. Even our most sophisticated mathematics might be incapable of describing the true beginning. Human mathematics evolved to describe patterns in the universe we observe. But what if the conditions at the Big Bang operated under principles so alien that our mathematical language simply can't capture them? It's like trying to describe color to someone who's been blind since birth. The framework for understanding just isn't there. Some theoretical physicists have suggested that entirely new forms of mathematics might be needed, geometries and algebras that don't yet exist. But even if we invented them, how would we know they're correct? How do you test a theory about something that by definition cannot be observed? The universe is 13.8 billion years old. Humanity has existed for roughly 300,000 years. Modern science has existed for maybe 400 years. We've made staggering progress in that cosmically brief moment, mapping galaxies billions of light years away and detecting gravitational waves from colliding black holes. But all of that progress, all of that knowledge, still doesn't get us past the wall. And it never will, because the wall isn't made of our ignorance. It's made of the fundamental structure of reality itself. You wanted to know why we'll never know what happened before the Big Bang. This is why. Not because we haven't tried hard enough or haven't built the right machines, but because the universe has written the answer in a language that might not be translatable, hidden it behind barriers that might not be penetrable, and structured itself in a way that makes the question itself potentially meaningless. The greatest mystery in existence isn't just unsolved, it might be unsolvable. And the universe doesn't care that we want to know. It keeps expanding, indifferent to our questions, carrying its secrets deeper into the unreachable past with every passing second. Thank you for watching. If you want to explore more about the limits of what we can ever truly understand about the cosmos, the next video dives into another fundamental barrier we'll never cross. I'd be very grateful for your support, and I'll see you next time.